Wait. So what is the laws of motion? Newton's laws of motion are laws of motion we used to study. So as we comes to know, in this universe, if you'll observe, always we have two kinds of objects. Can you able to say what is the objects? All of you. What is the objects? We have studied two things in balanced and unbalanced forces. Balanced forces always objects in what? Objects may be in rest or else maybe in uniform motion. Yes or no? Uniform motion. Others also should respond because we have studied. Always we can observe two kinds of object in this universe. Understand? That is what? Few objects may be in rest and few objects may be in uniform motion. Is it yes or no?
Yes, sir.
Yes. So now you see what is Newton's laws of motion. If you'll observe, Newton has given totally 3 laws to describe the motion of bodies. How many laws? He has given 3 laws which will describe the motion of, understand, bodies. So now that is only we used to call it as Newton's first laws of motion, Newton's second laws of motion, Newton's third law of motion. So these 3 laws also we can call it as, understand, Newton's laws of motion. What we should call? These 3 laws is only known as Newton's laws of motion. So these Newton's laws of motion will, understanding, precise the definition of force and make the, understand, and establish a relationship between the force applied on a body and the state of motion acquired by it. So that is what Newton's laws of motion will suggest us. Always Newton laws of motion will says that all the 3 laws, understand, first law of motion, second law of motion, third law of motion, 3 laws will they will say that they will give the definition of force, understand. And as we know that unless until external force is applied, means unbalanced forces, we cannot bring the body which is in rest to motion, which is in motion to rest. That is what we have studied in last class. Is it yes or no? Is it yes or no? Always
yes, sir.
Forces only we can create a motion in a body, or else we can stop a moving body. Is it true? Yes? Nobody will say.
Yes, sir.
Yeah. But if you observe here, these Newton's laws of motion, Newton totally given 3 laws for describing the motion of a body. Understand? So these 3 laws is only called as Newton's laws of motion. So this Newton's laws of motion will precise always. They will give you the definition of force, and as well as they will form a relationship between the force which we applied, understand, and because of that force, what kind of state of motion acquired by it. So that is only called as Newton's laws of motion. They always will form the relationship between the force which we are applying and the motion, state of motion acquired by the body is only called as Newton's laws of motion. So now we will discuss these laws of motion and consider some of their important applications. So let's start with the first law of motion. What will start, Ra? First law of motion. Do you understand? So somebody will ask you Newton's laws of motion. Newton has given 3 laws of motion to describe the what? Not stationary object, to describe the motion of a body. To describe what? Motion of a body.
Motion of the body.
3 bodies. These 3 laws will give the what? Always they will form a relationship between what? They will form a relationship between force applied and the state of motion. And the state of motion acquired by the body. That is what you should remember. The state of motion acquired by it. So that is what Newton's laws of motion will say. So now if you see Newton's first law, what we used to call as Newton's first law of motion. So let us discuss what is that. First you listen, don't try to write anything. Later you can understand. So we have totally 3 laws. So let us discuss now first law. So that is only called as Newton's first law of motion. Newton's first law of motion. Very easy. Newton's first law of motion. Observe all of it. You can do, even we will do some experiment also. Now, try to understand very carefully what is this. So as we know that in the universe we have two kinds of bodies. What is that bodies? Just now I have told you. Can anybody say? Monish, Tamil Selvan, hello, Alana. We have two kinds of bodies. What is that bodies? Few bodies which are always in rest and few bodies which are always in motion.
Motion.
So these two kinds of bodies we have. Understand that motion is also uniform motion, which we have studied. Now, try to understand very, very carefully. Some of bodies around us at rest. Some of bodies, or else we can call it as objects. Both are same. Do you remember? Few times I will use bodies and few times I will use objects. Both are same. So in our surroundings, if you'll observe, some of bodies around us are at rest. Means they are stationary. Is it yes or no? They are in rest means what? They are stationary position. Stationary position means in the sense of they are always at constant position. They are not moving anywhere. Now, like that, if you observe other objects, understanding, or other bodies, they are in always motion or else uniform motion. Now, what Newton's first law will describe means it will say the behavior of such bodies which are in a state of rest or state of uniform motion. It will describe the characteristics of which are state of rest or which are state of uniform motion in a straight line. Uniform motion always in a straight line. That is what you should remember. Always in a straight line. Do you understand it? Uniform motion always must be in a straight line. Now, what it will say is, what is Newton's first law of motion means? So according to Newton's first law of motion, now generally we'll discuss one thing, later I will say the definition. Suppose you tell me, I have kept some kind of football or some kind of object here. Do you understand, Ingra? Some kind of object here. Now, today I kept, tomorrow I kept. Understand? Day after tomorrow, next day, even 10 days I kept here and I observed. Unless until if I have taken, or else somebody need to push, or else air need to blow. Understanding? If all the conditions I have restricted, is it the ball will move anywhere, or else it will be same, remains at the same position? Is it the ball will move anywhere?
Remains at same position.
Yes? Others? It will be
Remains the same.
remains at the same position.
Remains the same
If
position.
you want to bring a motion in this body, what you have to do? You have to apply external force. Is it yes or no? You have to apply
Yes, sir.
external force. So if there is no external force, what will happen, Ra? All the forces are balanced so that it will stay always in the stationary position. Is it yes or no? Yes?
Yes, sir.
Now, the same way,
Yes, sir.
let's consider I am riding a bicycle, or else let me take now, Pradosh is riding a bicycle, understand? And he is always moving with a uniform speed, then nobody is stopping him, no air, understanding, and no brakes, nothing, and he is not even pedaling also, increasing or decreasing, or else something, nothing is happening, just his cycle is started moving in uniform motion in a straight road, then is it he will come automatically to rest, or else he will continuously in motion? He will continuously in motion. Nobody should stop. Air friction also. Air also won't be present. When he is in like that, continuously in motion. Which motion? Uniform motion. Understand? In a straight line. Then he will comes to rest or not? Tell me, uniform motion in a straight line. Is it they will comes to rest or not? Nobody is
No,
saying.
sir.
No. Is it a sir? So if he wants to comes to rest, first earth need to apply the friction, air need to apply the friction, or else he need to press the brakes, or else he need to stop the pedaling. Something should happen. So he is not doing any action and nobody is helping him to stop. so that he will be continuously in a uniform motion in a straight line. Is it yes or no? Manya, Samaya, Tamil Selvan, all of you will
Yes, sir.
Yes, sir.
Football. Football remains in
Yes,
state
sir.
of rest unless until the external force is applied. The Prados remains in state of uniform motion unless until external force is applied. If he wants to increase the speed, external force is applied. If he wants to decrease the force, external force is applied. Means in the sense of somebody needs to hold, or else somebody need to push, or somebody need to apply the friction in the form of air or earth to restrict the Prados speed, either increasing or decreasing. But nothing is happening. So that if unless until external force is applied to stop the body or else to make a motion in the body, both the cases we have to make it external force. Is it yes or no? External
Yes,
force.
sir.
By using something like air or me or some other or you or somebody. So if there is no push and pull in these two cases, this body remains in state of motion and this body remains in state of rest. Is it yes? Will you accept it? Will you accept it?
Yes, sir.
That is only known as Newton's first law of motion. That is what I have told you this example. See, simply saying definition and later giving examples is not a matter. So what is Newton's first law of motion means? Observe all of you carefully. A body at rest will remain at rest. A body at rest will remain at rest, and a body in motion will continue in motion in a straight line with a uniform speed. A body in motion will continue in motion in a straight line with a uniform speed, remains in same uniform motion. Is it yes or no? Remains in same uniform motion unless until external force is applied. Is it yes or no? Unless until
Yes, sir.
external force, it must be, unless it is compelled, means in the sense of influenced by a external force to change the state of rest or state of uniform motion. Is it yes or no? Is this or no?
Yes, sir.
That is only called as Newton's first law of motion. If you want to change the state of uniform motion, or else if you want to change the state of rest of a bodies, then both the cases, both the bodies must compel, understanding, by some external force. Understanding. Then only the body which is in rest may gain the motion, or else the body is in motion may gain, comes to the rest, or else may speed increases or speed decreases. So that is only called as Newton's first law of motion. What we should call? Newton's?
Newton's first law of motion.
I hope you all will understand very well. Is it clear? Manish?
Yes, sir.
Darun? Darun, are you having any doubt?
Sir.
That is only called as
Yes, sir.
Newton's first law of motion. Understand? Right, all of you. Newton's first law of motion. Newton's first law of motion. I will give you so many examples and we'll do practicals also now. Some experiment also. Okay? Right. Newton's first law of motion. First you keep heading Newton's laws of motion. Newton's laws of motion, and you write some points. You should know correct what it will describe. What Newton's laws of motion will describe. Later only Newton's first law of motion. First you write Newton's laws of motion. Newton's laws of motion. Keep today's date, everything. Date, day, and all. Can I say? Right now. Newton's laws of motion. Newton has given three laws of motion. Newton has given three laws of motion. Laksha, do you understand? Alana, you also please respond me. Do you understand?
Yes, teacher.
Yelamukil, right. Newton's laws of motion. Right.
Yes, sir.
Newton has given three laws to describe. Newton has given three laws to describe the motion of bodies. Newton has given three laws to describe the motion of bodies. Three laws to describe motion of bodies. Full stop. These laws are known as These laws are known as Newton's laws of motion. Newton's laws of motion. These laws gives a somebody will ask you what is the importance of Newton's laws of motion, but by the time you should write this point. Exam also few times may ask. Understand? These laws give a precise definition of force, precise definition of force and establish a relationship between the forces applied on a body, between the forces applied on the body and the state of motion, forces applied on a body and the state of motion acquired by it. Do you understand, Ra? Now you can keep first Newton's first law of motion.
Can you repeat?
Newton's first law of motion. Newton's first law of motion. All of you should keep reading. Newton's first law of motion. Newton's first law of motion. Shall we start now? So now, what it will suggest, right? Definition. A body at rest. Pradosh, you want to repeat it? So Pradosh wants to repeat, again I will repeat. Establish relationship between the force applied on a body and the state of motion acquired by it. Is it okay, Pradosh? State of motion acquired by it. Okay, da, Pradosh? So next you write Newton's first law of motion. You should write. A body at rest remains at rest. Comma, and a body in motion, will continue in motion. A body in motion will continue in motion in a straight line with a uniform speed, unless it is compelled by an external force, compelled by an external force to change external force compelled by an external force to change its state of rest or of uniform motion state of rest or of uniform motion. Do you understand?
Sir,
Yeah.
can you tell the definition again by
Okay.
network
Yeah.
connection? It will
A
throw me
body
out, sir.
at rest. Write it. Laksha, you also write. A body at rest. Will remain at rest. A body at rest will remain at rest. A body at rest will remain at rest, comma, and a body in motion will continue in motion. A body in motion will continue in motion in a straight line with a uniform speed comma unless it is compelled by an external force to change its state of rest or of uniform motion. Do you understand? Ra?
Yes, sir.
All of you, is there any doubt? You can ask me. Yes? So now, if you'll observe very carefully, this Newton's first law of motion having two parts. Is it yes or no? Boys and girls, everybody. It is having two parts. First part will say related to the objects which are in rest. The second part will say the objects which are in uniform motion. Yes or no? Yes or no?
Yes, sir.
Now, let us discuss. Understand? So, separately, part-wise. So, if you observe here, they are saying that, understand, an external force, understanding, we mean a force from outside the body, understanding, outside the body should need to apply either to change the state of rest or to change the state of motion. That is the meaning of compelled by an external force. We have to apply the force from outside the body. So that is only. So for example, let us discuss now some examples to make the first law of motion more clearly. Suppose, let me take now, understand, a book is lying on the table. So let us take now, for example, let me consider this is my book. Understand? So this is lying on the table. I have kept on it on my table. Understand? Lying on my table. Now, you tell me, is it in which state? Is it in uniform motion or is it in rest? Is it in uniform motion
Rest.
or is it in rest? This is my table and I have kept my book like this. Is it in uniform motion or is it in rest?
Rest.
Rest. Now, the book will not move by itself. Is it true? This book will never
Yes, sir.
move by itself. Yes? And this book, it cannot change its position of rest by itself. Even though if you keep 1 day, 10 days, 10 years, 100 years also, if the bench is existed like this, if atmosphere, nothing will change, no atmospheric forces also, then this book will be remains at the state of rest. Is it yes or no?
Yes, sir.
Yes, sir.
Yes or no?
Sir.
Now, you observe very carefully.
Yes, sir.
Cannot change its position by itself. Understand? So, it can change its state of rest. Only you can observe, see, when compelled by the force of our hands. If I will keep my hands like this, and if that is only called as outside force from through my hands, I am applying, I am compelling, understanding by the forces of our hands. Understanding means if I lift the book from the table, when we lift the book from the table, I'm applying force, external force with the help of my hands, so that the position of the rest of the book has been changed by the external force of our hands. Is it yes or no? External force of
Yes, sir.
our hands. Do you notice it?
Yes, sir.
So I'm applying, I'm compelling by the forces of our hands. Then only the position of the book is changing from here to here, or here to here, or here to here. Now, the book from the rest, it comes to the motion also continuously. If it is if I am applying force, then it will be in uniform motion also. Is it yes or no? Or else if I'll throw it, it will fall down and it will acquire the new position of state of rest. Is it yes or no?
Yes, sir.
Yes. So this observation, if you'll observe, by compelling the forces of our hands, understanding, I am giving external force to this book so that the book is changing its position, or else it is lifting, understanding, from the table, or else it is moving away from the table. So if you'll observe this understanding, so we can say that it will support the first part of the first law of motion. Is it yes or no? First part, the body which is in rest, it is support this example. Is it yes or no, Ra?
Yes, sir.
The body which is in rest remains in state of rest unless external force is applied. That is the example of this textbook. Now, let us take, as we know, understand. So here, the same way, like Pradosh example I have told, when he is cycling, there is no air friction, there is no ground friction, there is no applying brakes, there is no pedaling. Understand? Unless until he need to do some action, or else some action by atmosphere, he will always be in state of uniform motion in a straight line. Is it yes or no?
Yes, sir.
So there
Yes,
also,
sir.
if I want to stop him, I need to understand, pull him back. If I want to increase his speed, I need to push him. Like somebody should apply the external force, then only we can observe his position of understanding, uniform motion will change. So from that we can say that, understand, that will support the second part of the first law of motion. Will you accept it?
Yes, sir.
Yes. So now, let us discuss here only the question came. One more new phenomena involved in this. So if you'll observe here, the body which is in rest, the body which is in motion or else moving, you remember the tendency of a body to remain at rest or stationary, or if moving to continue moving in a straight line, that is only called as inertia. What we should call, Ra? What we should call?
Inertia.
Inertia.
So what is inertia? You can understand more clear once if I will explain the examples and some experiment. So inertia means, suppose, let me imagine this is Elamukil, understand? And this is the road. So now Elamukil is in rest, understanding, means in the sense of he is in stationary. He is in what? Stationary position. So here, this whom I said, Ra? Darun. So Darun, this is Elamukil. Understand? So Darun is in uniform motion in a straight line, straight road. He will be continuously, even though there is no external force, he will be continuously state of moving and he will be continuously state of rest or stationary. So that property of maintaining the state of rest continuously or state of motion continuously, that is only called as, what we should call, Ra? What we should call?
Inertia.
Inertia. Understand?
Inertia.
You can maintain a state of rest, or if you are moving, you can continue moving in a straight line. Understand? That is only called as inertia. So now, Newton first law recognizes that every body in this universe, if we take a small body, big body, understanding, another big body, whatever it is, understand. So if we take every body, Newton's first law recognizes that every body has some inertia. Every body has some inertia.
Some inertia.
Inertia.
So everybody has some inertia. Now, This inertia maybe increases or decreases. How it will be? What is the parameter decided? Now let us see. We will discuss it. So you remember, Yelamukini is trying to maintain its state of rest, and Darun is trying to maintain its state of motion. Understand? That is only we used to call it as what? What we should call?
Inertia.
That is only called as
Inertia.
inertia. Yelamukil wants to maintain his state of rest. Understand? Darun wants to maintain his state of uniform motion, so that they always trying to be in the same positions in the sense of he is trying to be in a rest continuously, he is trying to be in a uniform motion continuously. So that is only called as inertia. So if we take a smaller object or bigger object or very bigger object, every object having some inertia. That is what the Newton's first law will recognize as. And what is this Newton's first law? What is this inertia means? And remember, inertia is the property of a body. Inertia is a property of body due to which it can resist its change, resist a change in its state of rest or uniform motion. That is only called as inertia. Do you understanding, Ra? Now, Yelamukil is in rest and Darun is in uniform motion. So, if Prados is trying to come, understand, sir, spelling of this word, inertia, I-N-E, oh, inertia, correct, spelling is wrong. Spelling very good, Laksha. Correct only, I-N-E-R-T-I-A, inertia. Understand? So now, what is this inertia exactly means you remember? Suppose, Yelamukil is present here and Darun is present here. Now, Pradosh came, or else some other Tamil Selvan, let us take. Now, Tamil Selvan trying to change its position of Yelamukil means he is trying to apply some external force. Understand? He is trying to apply some external force and is trying to change its state of rest. But Yelamukil trying to resist it, understanding, and reminds he is trying to maintain its state of rest only. Like same way, Darun is moving in a uniform motion and some other wants to control him. Understand? Either need to increase speed or decrease speed, or else coming to the rest, trying to bring them rest, but still he will resist them and trying to maintain its uniform motion. So that is only called as inertia. Do you understand, Ra?
Yes, sir.
All of you?
Yes, sir.
Do you
Yes,
understand,
sir.
Ra?
Yes, sir.
Yeah. So that property is called as inertia. Inertia is the property of a body due to which it resists a change in its state of rest or state of uniform motion. Now, let us discuss when this inertia is more and when this inertia is less means. For example, let us imagine if the greater the inertia of a body, greater will be the force required to bring a change in its state of rest or state of uniform motion. All of you should remember. If suppose Yelamukil is having more inertia, then more external force we have to apply to change its state. As well as if Darun is having more inertia, I will say what is inertia, you just wait. More inertia, then we have to apply more external force to change his state of uniform motion. Do you understand? Greater will be the inertia, greater will be the external force required to change understanding of state of rest or state of uniform motion. If lesser will be the inertia, then lesser will be the external force required to change of state of rest or state of uniform motion. Do you people are understanding? Laksha, Manya and Samya?
Yes,
Yes,
sir.
sir.
Yes. Now, sir,
Yes, sir.
inertia. What is this inertia? Understand? What is this inertia means? Remember, mass is a measure of inertia of a body. Do you understand, Ra? What is inertia? What is inertia?
Mass is a measure of
Mass
inertia.
is a measure.
Understanding, mass of a body is the inertia of a body. So the body which is having more mass, then what is happening? more inertia. The body is having less mass, is having what?
Less inertia.
Is it yes
Less
or no?
inertia.
For example, to understand better, let us take, I think nobody in our life will explain with this example. For example, let us imagine, this is just for fun. I will never use girls' names, boys' names only. Let us imagine now, this is Pradosh. All of you trying to understand very carefully. First, Pradosh is in rest. Imagine, Pradosh is in rest. So now imagine, Pradosh is like, his weight is around, mass is around 500 kg. Just imagine, like an object I am saying. Understand? 500 kg. Now, let us take the Mavanish. This is Mavanish and his mass is, this is the mass of Pradosh. Understand? P, Pradosh. And this is the Mavanish mass. So Mavanish is around 300 kg. So now, you observe very carefully who is having, understanding, more mass and who is having less mass. This
Sir,
is
Prados having more mass.
Prados is having more mass and understanding Maunis is having less mass. Now, both are in rest position. Both are in rest position. He is also in rest and he is also in rest. Now, I will ask Yelamukil and Darun and as well as you can take Tamil Selvan, everybody you can take, and I will ask them to change their state of rest. Means in the sense of, I will ask them to make a motion in this Prados as well as Maunish. So in where you need to apply more force, either to Prados or to Maunish.
Sir, to Prados.
Others, girls, will you accept it? Whom you need to apply more force, Prados or Maunish?
Pradosh.
Prados. Why? Why?
Sir, he have more inertia.
He is having more mass. If he is having more mass, then more inertia. Understand? Because what is this meaning of inertia? Means even though the Elamukil and the Darun and Tamil Selvan is applying external force, Prados is having more mass so that still he will resist them and he will trying to maintain his state of rest. So unless they will apply more greater the force more than his weight, then only